ground, elevated urban 80 kilometers, and elevated suburban will be 160 and 160 at the grade. Service headway minimum will be 2 to 10 minutes, and the suburbs will be 30 to 60 minutes. Number of stations about 100. Number of trains will be also 100 for the rolling stock for the metro and the freight. Stadium, we were planning in the first 12 stadium, now been reduced to 8 to serve the World Cup. The high-speed passenger railway from to the Kingdom of Bahrain, the design speed for that will be 350 kilometers, which has been reduced at this point, and we've been talking to maybe change that requirement. Traction power will be elevated 25 kV. The journey time will be 55 minutes, and will be Central Manama will be 63 minutes. Passenger railway to the Kingdom of Saudi Arabia will be 250 kilometers, which is now would be probably in the average of 200. Number of the station in Qatar will be 1 station that connecting the from Salwa, and the traction power will be elevated. It will be electrified in the Qatar area, and probably will be dual to Saudi Arabia. Journey time to the Saudi Arabia will be 40 minutes from the border of Salwa Road to the border of Saudi Arabia. The freight line will be 25 electrified also in the area of Doha. Design speed will be 120 kilometers, and will be an axial load of 25 tons. What we're seeing right now is the development of Qatar project interaction with the development at this point. We have Doha, Bahrain Causeway. We will have the network of the highway is underway building, the airport, the new international airport, and the stadium will be worked in addition to the metro work will be. Just to show you that where is the Lusail city built compared to Qatar, and as just only a function of understanding the key map. Lusail city is located on the east coast of Qatar, approximately 15 kilometers north of the city center in Doha, the capital of the Qatar. The city covers an area of 38 square kilometers, waterfront land that master plan into 11.5 square kilometers of integrated and diverse mixed use. Just to show you that Marina district, which is Lusail's several districts, and one of them is Marina district that will be highly. This will be Fox Hill, Qatar Entertainment City, Kuzaifan Island, waterfront, commercial. And all these will be the new, all of it is district that will be built in that area. Gulf district, and in this section where it says the Krayan district will be the stadium, the new stadium, which will serve the 22 World Cup, and that will be the main stadium for the opening and the finishes of the event. Sorry that it's not working properly. Just should be quickly. As you know, this is almost 6 kilometers in length of the development, and that one will be why we chose the system. I mean, as you know, the Lusail City Master Plan consists of many land uses: residential, retail, offices, commercial, shopping center, hotel, school, medical and cultural facilities, plus the stadium, sport, entertainment and recreation area, utilities and wadis, road, rail, bicycle routes, pedestrian and public cars. Vision for Lusail City is to establish distinctive 21st century's iconic city which celebrate the special cultural and geographical heritage of Qatar and the Gulf region. To promote family-oriented sustainability environment that is destination of choice of Qatar people and international visitors to live and visit and invest in the free property opportunities. Also to enhance the capacity of the efficiency of and public transport. To provide opportunity to create more dynamic urban environment. Create environmentally responsible and sustainable means of transportation consists of a goal established by Lusail Master Plan, Qatar Integrated Railway Network. This is what we have in potential in transit of the market and trips from resident, employee, resort, visitors, shoppers. Just explaining what we are doing now. Typically, develop of the transit network would require the proposed area to service to be stimulated travel demand forecast. Understand how trip will be distributed through the area. We need to know provide an initial assessment on how trip will be made by automobile, transit services, and other model. Based on the Lusail transport demand and land use and traffic studies, it was determined that the most appropriate technology for Lusail transit system would be the tram system. Otherwise, we call it the streetcar. In the context of Lusail, trams offer a following advantage. But when we looked at the model for the transport model, we found out there is 360,000 cars will be serving and coming to the city. From that, we created the model of 20%, it's 116,000. Those 116,000 of the will be from inside Lusail. And from that, we developed what we call it the model of 20% of the 116 becomes about 23,000 ridership that will be used in the rail. So from that, what we did is the appropriate scale for Lusail transit, need the appropriate service for Lusail and how we did it, scalable transportation and solution, flexibility, and a proven technology. What we mean by proven technology, I will come back to it later on. The appropriate transit solution for Lusail require comprehensive and understanding of master plan. We had to look at the master plan because already master plan created, developed, and after that we introduced the transportation, we introduced the public transportation as looked at the city, what would be the best for Lusail. And we found out from all the study conclude from buses, studies, cars, metro, we found out that the LRT light rail system will serve the city and give it the needs that we need because of the district from businesses and from residential. That show you the Al Khor Highway, the main, the blue, which is the main roads that will feed Lusail. That will be the purple line shows the LRT and also the depot facility. The Lusail Light Rail Transit System parameters. From that, we looked at the system and how we will be working out. We found out that's 4 operation system for the 4-line operation system will be in Lusail. It's about 30.5 kilometers. Section about 19 kilometers at a grade, and 10 kilometers in a tunnel, 37 stations, 24 at a grade station, and 10 in the tunnel and the viaduct. The reason we went from, if you understand why did we go in a tunnel section for an LRT? Usually understand the streetcar that's needed for, it will be at a grade, most of this to use. Because of Lusail already developed their plan, and it was a big challenge for us how to implement the alignment in Lusail by having it in a section where a road already developed and the land has been used and sold. So if the developer bought the lands, we could not, was commitment for the development, and we could not expand and go rebuy back to expand the roadway to be able to put the LRT. So we decided to go an underground section of the Marina district. And that's why we say there's 10 kilometers of that in the tunnel, and was 10 stations that connecting to the metro, also connecting to the major cities and the per city in Lusail area. This is just give you the red line, that's the 4 operation line, which is the green line, red line, the purple, and the yellow line. The rolling stock, we are we always think about the future. We did not only specific for designing this for the period of time or the city. We had to think about what we will do in the future if the city actually developed and the ridership increased. So we made our plan to have additional vehicles for that. The required vehicle for the first phase is 34 vehicles, and from that will be increased to 67 vehicles in the future to be able to allow for the capacity, and especially now with the new stadium that will be built in Lusail, we will be able to have actually the rolling stock to be ordered in the area for within 2 years from that. That's the number of the station to show that the operation of the line. The depot and the green. Okay. Let me just go to the rolling stock right now and what we are doing in the system in Lusail as a city, iconic city of Lusail. They determined that they don't want to see any wire like in Europe. You see a lot of wires on old cars, cable cars. That we decided we don't want this kind of system to be friendly system and be safe. So we went to a new technology and to have the proven technology in Lusail by catenary-free system, which is, from that we went to different manufacturer, looked in Europe, we visited Europe and educated ourselves into what we can be able to use and what kind of system that we are. We already established the requirement what we need. We established a requirement that we need some kind of a catenary-free system, safe to operate, and that will be a friendly to public, without any fencing, without any protection to railway. So we found out that will be the best is to go and explore the ideas and what in the world, where is that we can be able to do the system. So we visited 5 different countries, and from that we went for Spain, CAF, Siemens in Germany, and Saldo, Italy, Alstom, France, and Bombardier. So this area we concentrated on this, and they have a form of technology that will be working for Lusail as a catenary-free system as required by Lusail. So from that, we made a pre-qualification that the system should be working on a proven technology. And we went through the whole process, and we developed the criteria to what we need actually from this, how we're going to be able to select the manufacturer on the rolling stock. We review the tramway innovative technology, assessment of manufacturer solution and capabilities, assessment of technical financial impact associated with each solution, infrastructure, operation, maintenance, and the rolling stock. For instance, just wanted to go a little bit into the system itself and how to see that one. Why did we look in that one in here for catenary-free system? Traction power was provided for Siemens inboard supercapacitor. That will be when it's rain only stop in the station, then will energized and move into, and will get also the acceleration. So the supercapacitor will get the power through between the stations. Ansaldo Breda, similar traction power collection is constant. The tram wave, they have a tram wave developed that power rail embedded in the track bed. It's part of the track. And the contact between the collector shoe and embedded traction power. The rail, instead of will be traction power like the metro, will be embedded in the track and will be safe actually to walk in. Only the area, the train will be energized under the train itself. I will show some little video about that one in here. Bombardier is also the same way they came up with the electromagnetic field, that the prime move system, inductive loop embedded in the track bed, no direct contact. Inductive loop are active only underneath the track, which is similar to under the tram, similar to the other manufacturers. CAF, also they have similar Siemens. Siemens will come with the traction power provided in board. That supercapacitor charge the train from through the station area. Alstom, as you know, if you look at the red section of that, that's where they get the power, statical power supply. The system uses as power rail embedded in the track bed. The contact between collector shoes and embedded traction rail. The power rail is powered as underneath the tram. Similar situation to Ansaldo and also to Bombardier. So how we're going to be able to determine from this which the best technology and a proven technology to do? And if you know, the proven technology right now is CAF. They have some kind of supercapacitor, and the section has been done in Spain. Then you have Alstom and Bombardier, and now they are working in the El Sufouh. We go in the Ansaldo. Ansaldo are working in, it was a tested track. And now they have a section in Naples, 800 meters is running, and they're working in that. That section has been built and operational at this point, and will be full operation by next month. That's how we get from the manufacturer. This is the one of these photo in Alstom and Bordeaux, and shows where as you see, the embedded rail into the section, that one here, embedded rail between the two rail, and that will be supplying the power to it. Is nothing. You could be able to work, and you see as a friendly, as much as you see, it's very safe operation. As you know, this is another section in the city of Bordeaux, and how the track is the embedment and the power supply to it. How did we decided to do the procurement and the job? We had from day one, Qatar Diyar, before we developed a new company called Qatar Rail. We were Qatar Diyar Development Company, that they have investment between shareholder agreement between Vinci company, and they call it QDVC, Qatar Rail Vinci company. They created a company, and in their shareholder agreement they gave them 3-4 projects, and one of them in the LRT, as understanding that will be developed as a turnkey project. So from that, we develop what we are a consortium. As you know now, right now we are a Ministry of Transport. We will have a rail authority. We were going to get an operator. The operator will manage. We have a shadow operator at this point. We are evaluating to bring up the final operator on board for the metro and the LRT, and for also the freight and the high speed. From that, QDVC developed a leader, management leader to the project with a consortium, and this is the consortium showing that one here. From the rolling stock procurement, that we gave all the system to under rolling stock, catenary free, train control, platform, screen doors, and power, the power substation, park power station. That's part of the rolling stock. Telecommunication is part of QDVC because there's a lot of the station and coordination interface, and that will be in the station. That will be should be part of the civil work. In the at this point of phases, we have the project started in the beginning. Lusail was developed and start development before even we have the master and finalize our rail. So we start working in the early phases in the 208 with the soil investigation and to see how we will do it. So they moved for the section because of the contractor. There's already contractor on board, and they were working in the on the roadway and utilities. So how we're going to be able to excavate our tunnel and work? So we had to release the work of the tunnel, the stations, underground station, at least to avoid the abortive work in the futures and reduce the cost of the project. So this section of the LRT, the green, where they show the green line, that all of it is underground from, and this is already built. We already built all that section, all the tunnel section already built, and we are building the stations. These stations already under construction at this point. Now from this point all the way down to here will be a connection with Lusail Highway. Lusail Highway will be work and connecting to the Pearl City. This is already built, backfilled, and I will show you some section of the tunnel that's already, and the underground stations, only the infrastructure because we did not choose yet the rolling stock. From what you see in the beginning of the job, as you see, you start from a point from 207, and we were going to finish on the 2016. That was the plan. And we still have the first phase now because of the project development and the city we're working in. We are working together with Lusail management because of the infrastructure together, and we had to delay the project movement to two sections, 217 and 219. The two section, the first section is 217, will be completed and operated on the first phase in the tunnel section and the depot, and the second phase will be the at grade because the city has been developing right now. It's not yet. So waiting for them to finish, and we start working on the, but we will be doing the whole work, and all the underground infrastructure will be done, just only the rail at the, and finalizing that plan will be done on the 2019. And that will match also the work related to the metro at the same time. This is what, just only to show you some of the work has been done, the tunnel construction, and that's the tunnel. Then this is the underground station, and how we've been working on it. This is the underground station's structure. As you see, the development of that, we have to do a lot of the planning interface because we are working on a kind of a design build turnkey, so we had to do some kind of an early development of the design to be able to finalize the project. And this is some shots of the stations. The final phase, which is right now we're working in the final phase by selecting the rolling stock. And from the rolling stock, we are negotiating at this point. We already have a recommendation to the executive committee. We selected 2 manufacturers at this point, and Ansaldo and Alstom are in the runner for this proven technology and for the catenary free, and will meet the requirement for Lusail and the Qatar Rail. However, we are waiting for the decision from the executive committee to give us the green line and start working and negotiating with the design builder. In this phase, at this point, we are also evaluating the commercial evaluation for the QDVC, the contractor, including the rolling stock and the power supply, which will be a full consortium, full project. So we are moving ahead at this point, and we expecting by the end of October have determination of how we will go, which was manufactured and either Alstom or Ansaldo, including with the QDVC. And now for the metro, as you know, for the metro we had RFP, and we selected contractor, and we gave them NTB for the red line, blue line, the green line, and the major stations of the Msharib and the airport and the Doha Center. These major stations are under work right now, all in the MBL work. Start working, the contractor get all NTB, and they start mobilizing their teams, and we are full speed with the metro at this point for 3 major contractors selected and consortium partner. The project cost, as you know, for Qatar Vision is about 140 billion riyal. And first phase right now is about, we awarded about 40 billion almost worth of work. This is also just only shots from the planning of the depot that for the LRT. Final phase will be the city of Lusail, and look how the train that will be in. So I'm going to talk about the challenges that we had, the challenge and that impact of the other projects too. Infrastructure development and adjacent development, alignment of the right-of-way, that we had a big challenge with that because it's already developed. Utility strategy, cooling strategy, and how we're going to cool the station. There is a district cooling, and that will Qatar Cool and some other companies that providing to us the cooling. Interface design and operation in for the model stations, tunnel construction and logistics, station construction and phasing and architectural work, and how we're going to be able to do by minimizing the impact of the construction for the traffic. And actually Doha right now is, if you see Doha, if you come, you're going to go about 10 kilometers, it's going to take you about an hour to reach that point, especially in the peak hours, because there's a lot of construction going on in the Corniche, and also for the highway, and for us to start rail and other project development. This is the city at this point. I'm sorry, go back a little bit. This is the city and how we started phase. This is the Marina District, and you could see, and a lot of the work has been going on. And actually we will almost finish the city complete in the same time as the Olympic Stadium will be done, and by 2020 it should be operational, full operation for the city. It goes back. Okay, this is the current activity of construction you see all over Lusail and over Qatar. If we look at this traffic, if you see the picture, this is what you see right now in Doha. This is what actually, if you go now, and the traffic after, especially today is the first day in the school, this is what you see. It's a lot of congestion of the traffic. It's about 1.9 million people working in the same small area. Doha is small, and everybody working in that section. Just only, and that's all the major construction, whereas you see from the activity of excavation and work that related to. If we're going to compare what we have done for the steel that we're going to use in this project, is about 150 times of the Eiffel Tower, about 80 million of cubic meter of excavation. That will be is about 32 times of the pyramids, and about 20 times of the amount of the concrete that we're going to use for the tunnels in Qatar and other projects. So it's a lot of work going on, and if you compare this for a small city, it's a big challenge at this time. What we face, logistic of the city is very, that's what we are concentrating on, and how we will be able to work to move of all these material, the tunnel work, TBM machine, constructed the cofferdams and start working in this section. Thank you, and I open the question if you have any questions.
Thank you very much, Mr. Shrafi.
Thank you.
Can I suggest you join us here on the panel?
Sure.
Because we're running a little bit late, and then maybe people can raise questions in the context of the panel. And could I also ask the two panelists please to join us, if we can encourage them to come up to the platform, please. Mr. Shrafi, it's an amazing project, what you're doing. I mean, it's enormously impressive. Can I just go back to something very early on in your presentation about the distinction between diesel and electric connections, traction systems for the main rail links? You were a little bit ambiguous on this. Do you think you're going to go back to a high-speed rail network with full electric locomotives?
Actually, at this point, we are, especially with the high-speed rail, the 350 kilometers, because of the GCC country and development, why we needed 350 kilometers in 100 kilometers, as Mr. Dr. Ramiz stated. The distance will be to go lower in operation, lower speed is going to make only difference 10 minutes or 5 minutes from where the destination that we needed. So to go and spend all that money, or the tonnage actually, because of, if you look before, they were looking for 32.4 axial loading. Why we needed that? Okay, 25 axial loading is plenty. So they were going to design the bridge for 32.4, and that's, imagine the differences between the loading itself. So that actually took a time for us to establish and agree on using that loading, the axial loading. Then after that, we moved to the speed. The speed, that's 350 kilometers. This is how that, but the logistic behind it, we are working on the process to see what will be actually the speed. This is the initial speed that we were working in. But you will allow yourself to have that kind of speed, but you don't need it through operation. As you know, for operation is not the same as the design speed. For the other one, I stayed that one because of the GCC country, you're connecting the freight or the commuter rail. And look in Saudi Arabia to connect that one here, they have DMU's car, which is that not how we're going to be able to work. If we need to reach to the point to the city, we are in the tunnels. So we need some kind of, we need to work at in how we will be able to get that freight or the commuter rail into the tunnel to the airports, the connection to the airport or or to the education city. That's where the connections. So how are we going to get those location? It's not at a grade. So that's the challenge where we say that we needed some kind of electrification to it.
If you allow me just to comment on this one, and don't quote me on the issue of Qatar high speed. Indeed, I was referring in my presentation, the private sector, the consultancy role is really to advise the client on the best way to do the business or the development of the railway within the constraints of the national requirements. The link between what they call the Doha Triangle up to the beginning of the proposed causeway between Bahrain and Qatar, it's about 110 kilometers. And in my opinion, the only reason that they have elected to go electrification is based on advice from their advisor, the consulting firm, and still at this time. And the main objective was really to bring students from Manama to Education City and be able to return back within an hour, so they were able to save 10 minutes unrealistically. And again, this issue, because the conditions and the information are different now, Secretary General, we are going to be working very closely with the state of Qatar to see, what could be done. It's not only that, also the proposal from the consultant to use, what they call concrete slab instead of the ballast slab. What that has caused constraint on the integration of the GCC railway, not in the on the interoperability. But in fact, just correction, the bridge would have been designed onto the 25-ton axle load. In fact, we have a very similar situation where the Sultanate of Oman has received, if I may call it quote unquote, an ill advice, where the same consulting firm who were doing the GCC railway advised differently on the use of electrification or electric locomotives versus diesel electric. And they have elected at the time, this was maybe 2.5 years ago, to use electric trains instead of diesel. So we've been working with them, and again, I'm very pleased to know that finally they have elected to use the standard diesel electric. So the point is, it's based on advice from the consultancy that the governments make a decision. I would say very strongly, if the conditions change, please go back again to these countries, advise them. There's nothing wrong, but you have new information available now, so maybe the decision will be very much different, and that's the case in the situation with the state of Qatar, and hopefully within this coming few months we will be able to revisit that issue in total.
Thank you. The interesting issue there is that technology on the diesel side is advancing very fast. So I think we're going to see almost a revolution in diesel technology in the next few years, which could also change the balance between the two different modes of traction, and that probably will make your decision the best decision.
In fact, the diesel electric, it's twofold. One is to have high speed, like the case in Qatar, and the other one to do with the environmental issues. And if California is using them, and as you said, it's very advanced and it's one of the most stringent in the world about the environmental safeguards, we have no problem with that. And that was the part of using electric train in Oman, it's an environmental issue. The part of using electrification, not only trains, is the high speed in Qatar. And again, the question, do we really need it? Do we need to spend that much money for saving about 10 minutes, if any? And the conditions has changed now, and hopefully that political decision also would reflect into these changes. So.
Okay, thank you. You can keep the microphone. The topic for our panel is understanding the importance of having a strong control on complex projects, and I think we've explored some of this already in the course of this morning. But I'd be grateful if I could ask each of our speakers just to talk a little bit about how they see that control process working from the perspective of government. Because obviously we're going to see this afternoon, we're going to see comments coming in from the providers, the project managers and so on. But it all starts with you, how you actually see that process developing, and how you give people flexibility to develop the project, but at the same time keep a strong control on its development, making sure that it hits its time limits, its financial limits and so on. So I'd be grateful if both of you could just give us a little bit of insight as to how you see that control process operating.
It's a difficult question to deal with, but actually when we started the development of the the project in Lusail. If we look at the, Qatar is, a lot of people questioning, and the challenge that we face from the governmental issues, why we needed a railway. Why we needed a railway for people, a lot of people, with respect to the local Qataris, they use a lot of, they use